Hello everyone, hope you're doing well. We are resuming again the series that we started, and today we are going to talk about how to identify missing and repeating numbers in array. So let's get started. So here is a problem that we're going to, today work on and find a solution of that. Let's say we have an array element in the range of 1 to n. So the assumption is that the numbers are from 1 to n. And then next condition is that one number from that set like 1 to n is missing, and also one number is repeating, so basically repeating twice. So one number is present twice and one number is missing. So we got to identify both what is which is a missing number and which is a repeating number. For example, as you can see, 313, 2 is missing here in the series, and of course 3 is repeating. Same goes with the next example, 4362111. So here 1 is repeating, and as you notice 5 is missing because we have number till 6. So you are 25. Okay, so how to go about it. So as always, there are several approaches for that. One is of course rudimentary, the one that you begin initially without bothering too much about their efficiency. So time complexity of course more here. As you get, I would say, new approaches, you get better. So the next approach you will see that there are two parallel loops basically. Time complexity is close to ON, and here you got to use one extra basically container, or you can say here dictionary we are using. Further refining, we just need a one array, not even two parallel array. So it's like ON, and of course the best is that we'll be using some math here. You already might have studied those kind of maths in 8, 9, 10, and also we're using simple math, and that does the job. So it is efficient because we're not using any additional, I would say, container there. Okay, so let's get started. Demo time. Okay, so let's jump to the, I would say, here. So I have made this test. As you follow the video, that's how we do. So text class, and here we'll call this test from program here, and we'll see how to go about it. So I'll focus more on the real logic, not on the logic that is kind of ready-made available. It's like taking inputs from user, and also that I have handy. So I'll kind of, I would say, use it so that we don't, I would say, we save time on that. We kind of focus on the logic that is worth investing time on, and you basically understand that. You focus on the core logic, right? So I think that's the intent. So here is a code that will ask the what is input size, and and it's try to first it will ask the size of the array, then it will ask the numbers that, hey, what's the numbers of those array, and it will take those numbers into this integer array. Okay, so pretty simple code. Now let's get started. So we'll write, as you can see, we talked about 4 different approaches, so we'll have 4 different methods to do that. So this is the first one where let's have this method here. Yes, and we'll code it. Okay, so as you notice, we till this point will have the array, right? For example, we talked about 313. So if 313 is coming, the answer should be that 1 is repeating and 2 is missing. So how to go about it? So for that, in the first rudimentary approach, what we'll do is we'll take 3 variables, and we'll see how that works. So let's take few variables to begin with. So int, say, repeat equal to -1, missing. Also, you can say -1, and let's take one counter. Okay, let's call it count equal to, of course. Initially, we can say -1 only. That's okay. Then we'll have a for loop, you know, and here we'll start from 1. The reason is that number starts from 1, right? Natural numbers. So that's the reason. And then what we'll do is we'll try to, so of course counter is initially -1, so we'll try to make it, here initialize 0, and then we'll so basically we're initializing 0. Then what we're doing is, as you notice, we're starting from 1 to n. And then we talked about this approach. We might need to use two loops, and exactly that's what the goal is. That in this we need to use two loops, and we'll use it well, as well. So how to use it? So for that, so initially 1 to n, we made this count to 0. The next loop will start from basically again. So let's call it j, counter j. So int j equal to 0, and of course, as you notice here, it is starting from 1, so it will go equal to length, and of course it's starting from 0, so it will go a less, 1 less, basically 1 less than nums dot length, and j plus plus, typical loop, no fancy logic here. So now the core logic is that, if you notice, if I is a number, that is a natural number counter. If I equal to array nums of j, so what we are saying is pick one number, loop across array again, and see if it is matching. If it is matching, means you got one number more than once. So what you will do, you increase the counter. Simple, right? You increase the counter, and now what do you do after that? So you pick one number, you iterate over it. If it is matching, you increase the counter. So basically, what you're doing is that if counter is, it is basically 2, means it came twice. If it didn't come at all, means it's it's not present, right? So that's the thing. So for that, we can simply have this condition, right? That if counter equal to 0, means I, what number is there, is a missing number. If it is 2, means it came twice, so it is a basically repeating number, and then we can simply get it printed. uh, Again, I'm kind of I would say using the snippet to save time, because this is not a core logic. Core logic we discussed. Core logic is this, that you iterate over 1 to n here, and again 0 to less than n here. You pick one number, iterate over it. If you find it matching, increase the counter. That's the core logic here. And if counter is 2, means it came twice, you say that, hey, you are repeating. If it's 0, you say, hey, you are missing. And once that is done, once you come out of loop, you simply print it, that this is repeating, this is missing, and you're done. Okay. So let's run this, and we'll see how this works. Okay. So for a simplicity's sake, we'll take, I would say, let's take maybe small array, and we'll see how this goes. Hope it is clear. This is the first I would say approach, and not much, but yeah, simple logic that is over here. Okay, first time compiling is taking. I hope there is no error. I don't foresee. Okay, it's coming. So yeah, sizes will keep it simple, 3 1 3, and as you can see, missing is 2 and repeating is 3, so it's working basically. Now let's refine next one. So in this, what we'll do is let's take a replica of it, like replica in the sense this method is structure, not the code, and we'll put 2 here, and we'll also put 2 in a calling so that it knows that yeah, I'm not orphan getting called. Okay, so what change we'll make here? Change will be, we'll refine it. So we'll not have the, so as you notice, it is a ON2, this one, and it is, of course, nobody will like it, right? It's not efficient approach for sure. So we got to refine it, and we got to bring into some expected level of performance complexity. And for that, since we are using this with C sharp, that's similar to I would say Java, right? So in this C sharp we have, in other languages they have hash map, hash table and all. In C sharp we have we have hash table also, but dictionary seems to be better, I would say faster and generic as well. So we'll use dictionary. So let's use dictionary, and we'll use dictionary of, let's say, internet. This will have a key and also value that how much it is repeating, and it will give not am, will give name, this. And then what we'll do is here we'll have one loop that will go for this will start from 0. Basically what it will do is that it will say that it will start from 0 and will go till, of course, one less than element. And the core logic here is that this dictionary right now, initially dictionary will have nothing. So if dictionary, so basically you keep adding numbers into the dictionary, right? And if the number is coming once, you are just adding one. So it's like a key value. So key is the number itself, and one is like it came once. So you keep adding key value. So the number that is repeating here, it will find the key already. So here it will increase the counter of it. So it will increase the value of it. So for example, 313, when the 3 will come, it will have a 3/2, right? It will have 2 is not there at all. So 2 won't be there. 3131 will come here and 1. So 1132 is how this is going to be formulated. So basically it is checking and adding accordingly. Now, so I think here you can expect 2 parallel loops, right, as discussed. So the one parallel loop will make sure that numbers are getting added into the dictionary. Other parallel loop, what we'll do is that it will check that whether the element in dictionary are like, for example, we see that we discussed that, okay, here in 313 case, one will have 1 and 3 will have 2. So the next loop will check that, okay, which number have 2 and which number is not present at all. So if number not present at all means it is absent, right? It's missing. And if number is having a counter 2, it means basically it is repeating, right? So simple code again. To save time, I'll use snip, and of course it's pretty straightforward. We'll explain it as needed. So the core logic, I think you understood. The core logic is that first we'll take a dictionary, we iterate over it. If we find a key, we'll increase the counter, like we see the value part of it. If not, then of course we'll edit. And second loop, what it does is it will check whether it has any number have a keys present, and it has a count as a value part is 2. If value part is 2, of course it is repeating. If the key at all is not present, for example 313 case 2 will not present on this at all, so it means it is missing. So it's pretty straightforward. And as soon as you found the repeating and miss both, then of course why do iterate loop, you can save some cycles and you can break it out and then print it, right? So again, we'll take the same simple example. Let's see if it works or not. So these are small, I would say, logics, but I think the goal is that you start thinking on those lines and you develop those. So again, 3, we'll take 3, 3, 3, 1, 3. So as you can see, it's also working. 3 missing is 2 and repeating is 3. So better, I would say, efficient approach than the previous one, and it's working again. Now I would say, let's take a even more efficient. So here, right, as you can see, we got to have 2 parallel loops. So complexity is little closer to 2 n, like n, but yeah, there are two loops, right? So we can even, let's see if we can do even in one loop. So again, we'll put it here, number 3, and also we'll call it from here. And here we go, number 3. What's different here? As I said, we'll have just one loop. You'll save some cycle again here. Okay, and let's close this. Okay. So in this logic again, you know, I would say I'll talk about the core logic. I'll focus on that. This code, I'll kind of reuse it. It's pretty simple. You will notice it. In the rest of time, it's not worth writing again from scratch, but so I'll reuse it. But yeah, you have seen this code. So no change. You will have this dictionary. You're iterating over from 0 to length. Like how much is this? Basically, it is the same code. If you see this, at least first part of it, right? Here it is all till here it's same. Instead of increasing the counter, we are breaking it out basically. That's the only change. Rest is same. So we are, if it is not matching, we are just storing into repeating. We are saying, yeah, hey, you are repeating, and we're breaking it out. So no change, no much change on this. So basically, this will help you to find out duplicate numbers basically, or repeating numbers. So again, you start from here. If you find the key, you will. If you find the key, you will basically means you. If you find more than once, if it already came in, if it is not there already in dictionary, you will edit it basically at 1, right? So you will have number and then 1. If it is already there, instead of I would say, in the previous example, if you see what we were doing is, we were, in this one, if you see, we were increasing the value part of it, right? We're increasing, hey, 3 you can twice, so 3 comma 2. Here we're not saying that. Here we are simply saying that, hey, 3, looks like you are repeating numbers, and then after that we are breaking it out. So this is only slight change on this the previous one, right? For the first part. In the previous one, we had we were with the similar logic we were finding 2. Here we'll change the logic. So for duplicate, we'll use this logic. For a missing, we'll use a pure math. And here you understand this, how this works. So the math is, if you remember your school days, to find the sum of first n natural number, the formula was n into n plus 1 by 2, right? So we're going to use the same formula. And how is that? Here you see, okay, the formula goes here. And the formula is, first we need to find that, okay, what is the, basically, how much array size is, right? So in this case, let's say 313, so it is 3. So basically you'll find the n here, okay? What is the, sum of the array? So this will come later, but understand this. Let's put this here so that it's easy to understand. So we found the n here, and then we're finding the sum of the first n natural numbers. So n into n plus 1 by 2, right? Same formula. So we got that, okay, if you're having 313, we'll take the same example so that it's easy to relate. So 313, hey, you are 3, your length is 3, so basically you're going till 3. So 1 plus 2 plus 3, 3, 2, so n into here 3, n plus 1, 3, 1, and 4, divided by 2. So 4 into 3 by 2, so 12 by 2, so 6, right, with this formula. And also if you add, so 1 plus 2 plus 3, so 3 plus 2, 5, 6, right, both are working. So it's just a kind of quick probing that they're working on it. So now, so how to find, so we found a duplicate that, here, but how to find missing? So first we got that, okay, for sum of first and natural numbers. Then we are going to have a sum of the numbers which are in array already, right? So this array will have 313, so 3, 3, 6, 7, right? So now we got the sum of the array element already which are in array. Now how to find a missing one? So we know that the sum of the first n natural numbers is this. In this case, let's say 6. Uh, so we get that, okay, it is 6. Now we need to minus it with, so what is the sum of the array already, right? We got it. And you also know that by this time that which is my repeating number, right? So it must have come twice. So I'll reduce it. In my this sum, I'll reduce it because it must have come twice. That's why it is repeating. And then both of them will be subtracted with the natural numbers. So we'll get the missing number, right? So we know the sum of all natural numbers, and we'll reduce the number which are in array, of course, minus the repeating number that came already, and we'll find the missing numbers, right? Pretty simple. So with a math and one array, we are able to achieve that, okay? And again, we'll get it printed as well, so to validate that yeah, it's working indeed. Okay. So again, in interest of time, we'll focus on the core logic because that's what it matters. This I just reuse it, snipped. Now let's run it and see if it's working or not. It's getting interesting, right, folks? So the same problem can be solved by multiple solutions. That's what is also, I display that, yeah, you can approach the problem in different ways. But of course, you got to find the best efficient approach. So again, 3, 3, 1, 3. And yeah, answer is no different. So missing 2 and repeating 3, though the approach got changed. And here it is much more efficient because we're just using one loop here, right? Other is math. Okay, now the next one is, the final one is most efficient is again the pure math, right? It will revise your schooling. Okay, so here we'll say 4 and here we'll also call it 4. We'll call this one. Okay, so let's see how this looks like, the pure math. And pure math is going to be even better because if you notice we are using container here, right? So container will increase the space complexity as well, though we are not bothered too much at this point. But yeah, we should know that, okay, we are increasing it. Here you will not increase because here you are not going to use any containers. So here we'll use the pure math. Okay, so what does pure math looks like? First we'll take this. Let's see this entire math and then we'll understand. I have the snip, so to make this save the time. So again, concept, I will focus more on core concepts. So first you find the, of course, length as we did in previous example as well. Then formula, math formula. So we'll use two formula here. Sum of the n natural number n into n plus 1 by 2 and sum of the squares of n natural number as well. So one formula will come here, n into n plus 1 into 2n plus 1 by 6, right? And both are used here. Now we'll initialize, we'll have to, we are using long because square may become long, like the length may cross it depending on how much you're using it. So we have taken a larger variable size here. We'll have two variable here to initialize, right? And then again we are looping it from 0 to n, no different as you see. So basically either we can use these ready-made methods like dot sums and dot this link query, or we can use a loop. So I have shown both actually. So if you want to use existing inbuilt method, you can simply say equal to num dot sum or num dot sum this, and you can I would say comment this piece, right? So to make a pure, I would say implementation, custom implementation, I am using the custom, regular, I would say I have looped it and I'm kind of edit those, right? But you can use these as well depending on what you want. Now here is a pure math. So this we are saying that the x is repeating and y is missing, right? So if you remember formula of x square minus y square, x minus y, x plus y, right? If you remember that. And this is the x, we are saying that, okay, this array sum, the sum of the array that we have, minus the this numbers sum that we got from this. We are doing this minus, so we are assuming like x minus 1. So basically val1 is x minus 1, and they are representing this. We have taken one more expression called x square minus y square, and you know that it is basically corresponds to x plus y and x minus y, and x minus y we already got, right? So it's a temporary value. Since we got this, so we are saying this is x minus y is val1, and let's say call it this val2. So this piece basically temporaries val2 into val1. So how to find the other one, right? How to find x plus y? So x minus y is already there. X plus y equal to, you know, this val1 divide by this, sorry, this number that we have temporary divide by val1, right? Then only we'll find the val2. So for that, this number we already have this this number, this val_t, and val1 we already got on this first step. So we'll divide. So we'll find x plus y. So at this point we have x minus y and x plus y both. And you know from algebra that if you have x minus y equal to something, x plus y equal to something, so you can find the number x, right? So again, if you do 2x y and minus y and plus y will go away, and it will have, you will have 2x equal to some number, and x equal to this divide by 2, simple math. So you will find the repeating number here, because x we are saying is repeating, if you notice here, and y we are saying missing. And once you find x that is repeating, how to find a y? Because you know that x minus y, you know the formula, you got a, this number is repeating is x, and you found the number already. So this number value, like x minus y equal to some value, right? You already got this value. So find that, to find the missing one, that is y. Of course, y will go this side, x minus val, this number will come, right? X minus val1. What is x? You find this number here, x and minus val. So basically simple math here, without using any additional container. And this loop is again optional if you're using an inbuilt container, inbuilt methods, you don't need to use this loop as well. So without literally using any loop, pure math, you can find the missing and repeating number. We have taken, again, just to revise, we have taken two formulas here. One for sum of, I would say, natural numbers. Other is sum of squares of natural numbers. I would say you do this in paper and pen and paper, you will find it's pretty simple, right? We have just simply taken, we have two equation here, x minus y equal to some number, and x square minus y square equal to some number. We have just put it here for simplicity. We got a val1 and val2, and then simple math, and we got this x and y. So with that, this is I would say most efficient and also we are not using any additional container here, right? So with that, we are almost towards the end. This code will go into this place, and this place is called this. You will find this code over here if you want to see one more time in case you missed something. And it's thanks again to these platforms. Some of those are like listed here. They really kind of help us with the problem statement at least, so we can solve this, right? So yeah, really appreciate their contributions in community. And here is a bit about me, who am I and what I do. So this pretty much. Thanks everyone, and I would say if you want to be notified for next video, feel free to subscribe and comment, and for any suggestions, and take care.